Hello everyone, my name is Aafaq Sabir and I am a PhD student at North Carolina State University. Today, I'll be presenting our work on analyzing user perception and awareness regarding third-party Alexa skills, co-authored by Lafontaine and Dr. Anupam Das. Smart home assistants such as Amazon Alexa have become very popular because of their convenience and usability. These assistants are typically operated through a voice-based interface. Amazon Alexa can run apps called skills to enhance its basic functionality, and these apps can also be created by third-party developers. Like any other smartphone application, skills can collect sensitive personal information such as phone number or home address of the user. Therefore, it is important to analyze if users are able to differentiate whether they are interacting with a third party or a native skill. In this paper, we seek answers to the following research questions. First, we analyze if users are able to distinguish between third-party and native skills. Then we figure out that with Alexa's auto-enable feature, can users predict which skill will be activated when invoked? Lastly, we determine how can Alexa better inform its user about the ownership of the skills they interact with. For our analysis, we recruited 52 Alexa users through Facebook groups and Reddit forums and conducted an interactive user study that involved various tasks such as listening to interaction with different skills and invoking different skills using Alexa's smartphone application. Through this user study, we evaluate Alexa's security and privacy indicators that help users distinguish which type of skills they interact with. We evaluate visual and audio security indicators of Alexa through skill webpage and voice interface respectively. We designed an interactive experiment to analyze users' mental model about automatic skill invocation and tested if it's consistent with the Alexa's actual working. Finally, we leveraged the fresh experience of our participants to suggest privacy-preserving interventions in Alexa's audio interface. Although Alexa skills can be enabled using voice interface, users can also enable and get information about a skill from skill webpage on Alexa's skill store. So we analyzed and compared both visual and audio interfaces of skills to evaluate how easy it is to infer skill type from both interfaces. For visual interface analysis, participants were asked to visit web pages of 3 different skills through the provided hyperlinks and were asked to identify third-party and native skills. Whereas for audio interface, participants listened to the audio recordings of the interaction with 3 other skills. 2 out of 3 skills were actually from a third party in both cases. Participants were asked how confident they were with their classification on a scale of 4. From the skill web pages, we found that 80.8% of the participants correctly identified the skill type for all 3 skills. 82.7% of the third party and 94.2% of the native skills were correctly identified. We found that 59.3% of the participants who were correct were also extremely or fairly confident. Hence, we concluded that visual security indicators are very effective in distinguishing third-party and native skills. Skill web pages had very effective indicators that helped users to identify skill types. However, results were very different in case of audio interface. We found that 44.2% of the participants identified all 3 skills incorrectly, while only 36.5% participants identified only one skill correctly. Only 3.8% participants responded with all correct answers, and only 31.7% of the third-party skills and 15.3% of the native skills were correctly identified. Moreover, participants were not very confident in their answers, as only 9 out of 52 were very confident and none were extremely confident. Hence, we conclude that audio interface lacks good security indicators and the boundary between third-party and native skills is not very clear. When comparing the results for the visual and audio interface, we found that for most of the time, participants not only failed to identify the skill type correctly, but they were also not confident about their answers. However, we observed high correctness and confidence levels in case of visual indicators on skill web page. This suggests that identification information related to skill is present on the skill web page, but this information is not conveyed through audio interface. Considering each skill type separately, we found that users incorrectly classified both third-party and native skills in case of audio interface. If we think of this as a classification experiment, we found that 71 out of 104 third-party skills were false positives and 44 out of 52 native skills were false negatives in case of audio interface. This shows that participants even performed worse than random guessing, as third-party skills appeared to be as native to most respondents and most native skills were mistaken as third-party. The precision and recall for audio interface classification was 42.8% and 31.7% respectively. However, we observe 96.63% precision and 82.69% recall in case of visual interface. When a user says an invocation phrase, Alexa automatically enables a skill that matches the invocation phrase. First, it looks for the native skill, and if found, it is enabled. But if not, then it looks for a third-party skill and enables it. Multiple third-party skills can share the same name and invocation phrases, so Alexa enables any one of them based on an internal selection criteria that is not known to public. So the question arises, can users predict which skill is enabled when they utter an invocation phrase? To answer this question, we asked participants to search for a particular skill on the Alexa app and predict which skill they think will invoke if they say its name. Participants predicted one of the skills they thought should invoke from the search results. Participants were then asked to invoke the skill on Alexa app on their phone by saying the provided invocation phrase. Then they were asked to report which skill was actually invoked through the Alexa app. They were guided with step-by-step instructions on how to get the enabled skill information from the app. We found that 34.6% of the participants incorrectly predicted all three skills. Only 5 participants got 2 out of 3 skills correctly, and only 1 participant predicted all 3 skills correctly. 40.3% participants were fairly or extremely confident even though they guessed most of the skills incorrectly. This shows that user mental model does not align with Alexa's skill matching process, and users can unknowingly share sensitive information with potentially malicious third-party skills. In order to improve Alexa's voice interface, we created 3 different variations of interventions and asked participants to rank them according to the efficacy of privacy indicators. Model 1 consisted of a warning message and adding developer name in skill's voice interface. Model 2 suggests changing tone when third-party skill is invoked. Model 3 consisted of a warning message followed by a tone change as well as adding the developer information. Model 1 was ranked first by the participants. Model 3 and 2 were ranked second and third respectively. Based on our analysis, we provide recommendation to Alexa to improve skills voice interface in terms of privacy indicators. We recommend mentioning the skill's developer name when invoking a third-party skill. However, a warning message should be included when auto-enabling a third-party skill for the first time only to minimize the effect on user experience. We leave studying other possible interventions and their optimal frequency as future work. That's all for my presentation. I'll be happy to answer any questions. Thanks for listening.